In this lesson, we will be discussing about related rates, or in other references, this is called time rates, or these are applications of derivatives with respect to time, or quantities that changes with respect to time. So in this particular topic, we will be restricting our problems to problems involving algebraic functions. Kasi hindi pa tayo nakapag-discuss about transcendental functions. So I think the procedure in solving related rates problems could be well explained if I just give an example. Okay, let's try this problem. Let's call this problem 7.1. Water is flowing into a vertical cylindrical tank at the rate of 24 cubic feet per minute. If the radius of the tank is 4 feet, how fast is the surface rising? Okay, so I think madali lang naman maintindihan yung problem. So sabi sa problem, merong cylindrical tank. So let's draw that figure here. We have a cylindrical tank, vertical cylindrical tank, so meaning it is right in this position. Anyway, so yan yung shape ng tank. So of course the tank is a constant shape, diba? So it will not change. And it is given that the radius of the tank, so dito mo na lang ilagay, the radius of the tank is 4 feet. Now, water is flowing in. So may pumapasok na tubig at a rate of 24 cubic feet per minute. So that means that for every minute, sa kada minuto, may dumadagdag na 24 cubic feet. We know that cubic feet, that pertains to volume, di ba? So meaning, yung volume ng tubig sa loob, kasi yun yung nagpo-flow na tubig, yung volume ng water sa loob is increasing at this rate, 24 cubic feet sa kada minuto. So therefore, ang 24 cubic feet per minute, this is the rate of change of the volume with respect to time. So ito yung dV over dt. Diba? And that volume is actually this, diba? Yung nagfo-flow na tubig will comprise the water inside the tank. So ito, diba? It will be filled with water inside the tank. Right? So, that means variable yung volume of the water inside the tank because it changes over time. So, constant yung shape ng tank. The dimension of the tank is constant. But the water inside the tank, or the volume of the water inside the tank, is a variable. And also, of course, common sense, habang pumapasok yung tubig sa loob, the surface level, or the height of the surface of the water inside the tank is also rising. So therefore, this height is a variable. Let's call that h. Okay? Now, sabi dito sa problem, how fast is the surface rising? So what we are trying to get is the rate of change of the height of the water inside the tank with respect to time. Diba? So basically, we are trying to solve for dH over dt, the change in the height with respect to time. Okay? Now, how do we link, looking at the figure, how do we link the variables and the constants? Okay, ganito yon. If you want to compute the volume of the water inside, then the water that is inside the tank is taking the shape of the tank, which is also a cylinder, with radius equal to 4 given and this variable height h. So meaning the volume depends on the height. Diba? So these are now our dependent and independent variables. Diba? So if we want to compute the volume inside the tank in any particular time, that would be volume is equal to the volume of the cylinder, of this cylinder, diba? Which is just equal to pi r squared times h. And in this case, given na yung r natin, yung radius. So we'll change our formula as volume. So again, this pertains to the volume of the water inside the tank. That's equal to to pi times 4 squared times the height. or volume is equal to 16 pi, 16 and pi are constants, times h. Okay, now let us get the derivative, or let us solve implicitly this function with respect to time. Kasi yung quantity natin kasi is changing with respect to time. So, by implicit differentiation, we'll get the derivative of this with respect to time. So, the derivative of the volume with respect to time is just equal to constant 16 pi times, of course, the derivative of h with respect to time. So, that is just dh over dt. Again, we just copied this because constant naman siya. Then derivative of this is just this. And we have 24 as dv over dt. That's given. Ayan, 24. So therefore, we'll have 24 cubic feet per minute. That's equal to 16 pi dh over dt. Then we could just solve for dh over dt. Solving for dh over dt, that would be 24 over 16 pi, which is equal to, then gamit na tayo ng calculator. So that would be 24 divided by 16 pi, so 0.48. That's 0.48 feet per minute. It's feet per minute kasi ito, cubic feet per minute over ito, this is feet squared because that's radius in feet then in square. So yung may iwan is feet per minute. So sa kada minuto, nag-increase siya ng 0.48 feet. So that is our answer. So state natin yung answer. Therefore, the water surface is rising at 0.48 feet per minute. Okay, ayan. So that is our answer. Very simple lang. So, kung i-summarize natin yung procedure na ginawa natin, number one, we need to understand the problem. If we understand the problem, then we can identify the constants and the variables in the problem. Then, we need to draw the figure if appropriate. So, in this case, we draw the figure. So, from the figure, we can extract out the needed formulas. For in this case, the formula for the volume of the water inside the container, which is this. Then after that, we just need to get the derivative with respect to time. So implicit differentiation yung gagamitin natin because our variable the changes kasi is with respect to time. So we need to get the derivative with respect to time. So we are not taking dv over dh here, but we are taking dv over dt. So with respect to time yung pagkuha ng derivative natin. Then just solve. Substitute whatever is needed to be substituted. Then we give a conclusion stating our answer. Yun lang. So that is very, very easy. Okay, let us proceed to the second problem. A ladder 20 feet long leans against a vertical wall. If the top slides down at the rate of 2 feet per second, find how fast the lower end is moving when it is 16 feet from the wall. Okay, so this is just a simple problem wherein a 20-foot long ladder is resting or leaning against a wall. Okay, so i-drawing lang natin yung wall, so that would be like this. Halimbawa, ito yung wall. So, highlight natin konti. So, let's say right here is of course, the surface, the ground surface. A 20-foot ladder is leaning against this wall. Of course, it would be like this. It would look like this. Let us use ito na lang. Like that na lang. So this is now our ladder. And it's leaning against the wall. Of course, the other end is resting on the surface. Okay? Now, the ladder slides down, or the top of the ladder slides down. So, ganito. Ito siya is moving in that direction. Of course, since the ladder does not stretch, di ba? This is constant, or the length of the ladder is constant. So meaning, while this is sliding down, of course, this will slide in that direction, right? So therefore, at a particular time, yung position ng ladder natin will change. So ito siya ngayon, then mag-slide siya ganyan, then ganyan, then ganyan, then ganyan, hanggang matumba na siya dyan. Diba? But this length will still be the same because that's a constant. So in this particular problem, yung constant natin dito na una is of course the length of the ladder. So let's label that. Ito siya. This is a constant which is given to be 20 feet long. Okay? Now, what are the variables here? Of course, if this ladder is moving downward, okay, let me use this one. If this ladder is moving in that direction, therefore, its height dito, ito siyang height, is changing. So that is a variable. We'll call that y. Okay? Then, ito siya, of course, as this slide down, syempre gaganon yung position niya. It will be like this, then like this. So, ito siya, yung distance from the tip to the base of the wall is also a variable because this will also change as it slides down. So, ito siya is also a variable. Let's call this x. And the ladder, the other end of the ladder is sliding in that direction. Now, ito yung sabi dito. The top of the ladder slides down at the rate of 2 feet per second. So, bawat second, it slides down 2 feet. Sa bawat segundo, 2 feet yung ibababa nitong distance. Okay? So, therefore, ito siyang y. Kung if that is y, therefore, the rate at which y is decreasing, in this case, y is decreasing, diba? The rate at which y is decreasing is equal to 2 feet per second. Hence, dy over dt, ito ng rate, dy over dt is 2 feet per second. Ulitin ko, it is because y is decreasing 2 feet for every second. Yun yung sabi dun sa problem. Now, since the effect of this movement is to decrease y, therefore the rate is negative, diba? Because the effect is to decrease. So, meaning, to be exact, this should be dy over dt. The value of dy over dt is negative 2 feet per second. Okay. Dito naman, we notice that x is increasing. And then, the rate at which x is increasing is, of course, dx over dt. And we'll be expecting the value of this is negative because, we'll be expecting that the value of dx over dt is positive because that effect or that movement increases the value of x. Okay? With this given and these variables, we can now create an equation linking these constants and variables. And that would be a Pythagorean equation, diba? Pythagorean theorem, because this is a right triangle. Hence, we say that x squared plus y squared, ayusin natin. So from the figure, x squared plus y squared is equal to 20 squared. Okay? Now, if we get the derivative of this function with respect to time, that would become 2x, implicit. 2x dx over dt plus 2y dy over dt is equal to 0. So we could just cancel out 2. So x dx over dt plus y dy over dt is equal to 0. X is unknown, of course. Then, ang kukunin natin is yung dx over dt. Ito yung yung ina-ask ng problem. Find how fast the lower end is moving. So, what we are trying to get is this rate. Because that is the rate at which the lower end is moving at that direction. Okay? So, hinahanap natin is dx over dt. So, yung required sa problem was, kung ayusin natin dito, yung required sa problem is to get dx over dt when x is eto. Ayan o. when it is 16 feet from the wall, meaning this end is 16 feet from the wall. Diba? Variable siya ang x, pero we were given this condition that x or at x equal to 16 feet. Parang ganito ba? Of course, at yung pag-lean or yung position ng with the position and the situation given this problem, the value of x is a variable. X is a variable or this distance is a variable, di ba? But what we are trying to get is how fast is this moving or how fast is this increasing when the value of x or umabot na siya dun sa point na 16 yung value niya. Di ba? When x is equal to 16. So this is our condition. When x is equal to 16. So this is our required for this condition. Okay? So dito natin ilagay dy over dt given na to as negative 2 and we need eto, condition natin when x is equal to 16. So when x is equal to 16, we could solve for the value of y, diba? Because we know that x squared plus y squared is equal to 20 squared or 400. So solving for the value of y, that would be 16 squared plus y squared is equal to 400. So masolve natin yung value ng y. So y, that would be 400 or dito na lang, that would be square root of 20 squared minus 16 squared, which is 12. So y is 12 feet. So ibig sabihin, when x is 16 feet, y is 12 feet. And the rate of change of y is negative 2. Okay, so what would be the value of dx over dt? So balikan natin tong formula. Ito, we'll go back to this and just substitute. So copy, paste, then we'll just substitute. X is equal to 16, dx over dt is unknown, plus when x is 16, y is 12, times dy over dt, which is negative 2, equal to 0. Therefore, dx over dt is equal to 24 over 16, and that would be equal to, which is equal to 1.5 feet per second. So that is our answer. Therefore, the lower end of the ladder is moving at a rate of 1.5 feet per second. That is very easy. Okay, let's answer the next problem, problem 7.3. A small funnel in the shape of a cone is being emptied of fluid at a rate of 12 cubic centimeters per second. The height of the funnel is 20 centimeters and the radius of the top is 4 centimeters. How fast is the fluid level dropping when the level stands 5 centimeters above the vertex of the cone? So we'll start this by, of course, let us illustrate a figure. So that would be a cone with 4 centimeters at the top and an altitude of 20 centimeters. Okay, now, so there's a fluid inside of the cone and it's leaking at a rate of, let's say this is the fluid. So we have a fluid inside of the cone and it's leaking. It's leaking at a rate of 12 centimeters per second. So let's draw this properly. That would more or less be like this. So sabi dito, it is emptied of fluid at a rate of 12 cubic centimeters per second. So meaning nagli-leak out yung fluid inside the container, which is a cone, at a rate of 12 centimeters per second. So ito, ang rate of paglabas ng tubig is, rate ng paglabas ng fluid is 12 cubic centimeter per second. So that means, ito yung change of the volume inside because ito yung lumalabas sa container. So therefore, at every second, may nawawala na 12 cubic centimeters sa container. So that is the change in the volume of the fluid inside for every second. Diba? So the volume, this volume is actually this volume inside the container, diba? And it's because it's leaking out, the fluid is leaking out, it is decreasing at a rate of 12 cubic centimeters sa bawat second. So since the effect of this dV over dt, which is 12 centimeters per second, is decreasing the volume, that means this quantity should be negative 12 centimeters per second. Because of that, of course, by common sense, the level of the fluid inside the container is also a variable. It is decreasing. So we have H. And if it's decreasing, therefore, there's also a change in the height or the altitude or the elevation of the water with respect to time. Okay? And also, if you notice, as the fluid level is dropping, so is the circumference of the surface decreasing, right? Palit ng palit yung circle natin. So therefore, the radius is also a variable because this quantity changes. So meron din siyang rate, meron ding rate ang radius with respect to time because it is changing. Okay? So yan. So our variables here now are the volume, the elevation of the volume, and the radius of the volume, which is a cone. Okay? Yung constant natin dito is of course the cone because the container will never change its dimensions. It's a constant. So we have volume. If we get the volume at a certain instant, if you want to get the value of the volume inside of that circular cone or that cone container, we need to use the formula for the volume of a cone, which is 1/3 pi r squared h. Okay? And remember na yung volume natin, if we get the derivative of this with respect to time, that would be dV over dt. And meron pa tayong dalawang variable, which is r and h. So we need to express one variable in terms of the other. So we'll look at our figure to connect the two variables through the constants. So if you look at the figure, kung side view yung titingnan natin, this part is a right triangle, diba? With radius and altitude, which is similar to this part of the cone, diba? Which is also a right triangle with this 20 centimeters and this 4 centimeters. So we could form two similar triangles from the figure. So kung i-drawing natin siya, that would be, let's say this is the container. The dimensions would be, this is 20 centimeters and this is 4 centimeters. Okay? Then we have a fluid inside. Let's say ito siya. Ito yung fluid na nagli-leak. So therefore, this radius here is changing. Okay, ito siya dito. As well as the elevation of the fluid surface, h. So by similar figures, ratio and proportion, we could say that the proportion of r, the ratio of r is to h is proportional to the ratio of 4 is to 20. So we'll have r is to h as to 4 is to 20. So therefore we have r is equal to h over 5. So we just transpose this and 4 over 20 is 5. O 1 over 5 pala. Ayan. So we could now substitute this value of r to the equation of the volume para maisa na lang yung variable natin, h na lang. So if we do that, we'll have volume is equal to 1/3 pi times h over 5. So that would be our r. So we replace that or we substitute h over 5 squared times h. So we'll have volume is equal to 5 squared is 25 times 3, that's 75. So we'll have pi over 75, h squared times h is h cubed. So we have now the volume in the formula of the volume of this container, the fluid inside the container. Okay, so our volume now is volume is equal to pi over 75 times h cubed. if we get the derivative of, because diba, the volume is changing with respect to time, if we get the derivative of the volume with respect to time, we'll have dv over dt. So implicit lang yung approach. That would be equal to pi over 75 times the derivative of h cubed with respect to time. That would be 3 times h squared times, because implicit, we need to multiply this by dh over dt. Okay, so let us simplify. We'll have dv over dt is equal to pi over 25 times h squared dh over dt. So if we apply our condition, remember that the volume is decreasing at a rate of negative 12 cubic centimeter per second. And ang hinahanap natin is, sabi dito sa problem, what would be dH over dt? So, how fast is the fluid level dropping? So, meaning, eto, ang level, fluid level. So, how fast would be dropping when the level stands 5 centimeters above the vertex? So, kung nandito na siya banda, when this is only 5 centimeters na lang. Because the side or the lateral surface of the cone is slant siya. So, therefore, at certain or at different points pababa, iba-iba din yung rate niya ng pag-decrease. Diba? Mas mabagal siyang mag-decrease dito, this mas faster siya along yung malapit ng maubos if you observe in real life. Okay? So yung tanong is, what would be, gaano siya kabilis bumaba when the level is 5 centimeters na lang above the vertex? So meaning, the condition would be, what is dH over dt when h is 5 centimeters? So yun yung isosolve natin dito. So, when h is 5 centimeters, what would be dh over dt? So, we just need to substitute. We'll have 12 cubic centimeters per second. That would be equal to pi over 25 times 5 centimeters squared times dh over dt. So, if you notice, we could just readily cancel this out. Okay? So, maka-cancel out din yung centimeter squared dito. Then, we'll be left with centimeters. So the value, no, the unit would be centimeter per second, which is the unit of the rate of change of the height. So we have dh over dt, that's equal to negative 12 over pi centimeter per second. And if you notice, the result is negative because, of course, as the fluid is leaking out, H is going down. So if H is decreasing, therefore, dH over dt should be negative. That's why yung lumabas na answer natin is negative. So the answer is dH over dt is equal to negative 12 over pi, which is equal to, kung i-calculator natin, that's 3 point something because that's 12 divided by pi. So 3.82. So that's equal to negative 3.82 centimeter per second. So this is our answer. So let's answer problem 7.4. A light is at the top of a pole 80 feet high. A ball is dropped from the same height of 80 feet from a point 20 feet from the light. Assuming that the ball falls according to the law, S is equal to 16t squared. So this should be familiar to you because nasa physics to. How fast is the shadow of the ball moving along the ground 1 second later? Okay? So, illustrate natin yung problem. So, first we have a light pole at a height of, or with a height of 80 feet. Okay, so drawing muna natin yung pole. Let's say this is the pole. So, yan. Let's say that is the pole and the height of this is 80 feet. Okay? Then, sabi dito, a ball is dropped from the same height. So, from this level, merong dinap na ball from a point 20 feet from the light. So, from this light, 20 feet, eto yung location ng ball na di-drop. Or, let's say, dito na lang. So, if this is 80, if this is 80, so 20 is just right around here. So, let's say this is the location or the initial position of the ball. And this is located at 20 feet from the light. Okay, So the ball would be, syempre, it would be dropping like that at this law, which is, actually, this is, distance is equal to initial velocity times time plus acceleration times time squared over 2. So wala tayong initial velocity because the ball is dropped, and the acceleration due to gravity in feet per second squared is 32.2, or in many books it's just 32. So 32 divided by 2 is 16. That's why we have 16 t squared. So yan siya. But anyway, if the ball is dropping, ito yung distance that it will cover at a certain time. And that would be, ito yung S. Ito na siya. So at a certain time, may ika-cover siyang S. Okay? So S is equal to 16t squared. We know that. Okay? Then sabi, assuming that the ball falls according to this law, how fast is the shadow of the ball moving along the ground 1 second later? So ganito, when the ball is right around here, yung shadow niya na makakast is at this point in the ground. So lagyan natin ng ground pala. Ito yung ground. So when the ball is right here, ito yung shadow niya dito. When the ball is right here, ito yung shadow niya dito. When the ball is right here, ito yung shadow niya dito. And when the ball is at the ground, of course, andyan din yung shadow niya sa ground. No? Because yun yung makakast ng shadow from the light. Okay, nakuha nyo? So let's say, at a certain point, andito na siya. Variable point. A certain variable point, andito na siya. So that means the casted shadow is at this point. Ayusin natin. Okay? So yung shadow niya is right around here. Okay. And as this ball moves towards the ground, the shadow also moves toward this point. Okay? Which is 20 feet from the base of the pole. Okay. So identify na tayo ng mga variable. Of course, our variables here are eto, and also this distance, right? That's a variable. So let's call this distance, eto na yung x natin. So let's call that distance x. Pwede to siyang y, but the value of y just depends on the value of s, because y is just 80 minus s, right? The value of y is 80 minus s. Okay? Pwedeng ganun. Ano yung hinahanap natin dito? Sabi, how fast is the shadow of the ball moving along the ground 1 second later? So the movement of the shadow along the ground is eto, di ba? Movement niya from here to here. So as the shadow of the ball moves from here towards dito, the value of x is decreasing, right? So therefore, ang hinahanap is yung dx over dt, or the change in the distance from this point to the shadow, or dito, change in the distance from this point to the shadow with respect to time. And we'll be expecting that dx over dt should be negative, okay, because the value of x is decreasing. Okay, so how do we get now the formula? Meron pang condition. What would be dx over dt 1 second later? So, dx over dt yung hinahanap natin when t is equal to 1. T is equal to 1 second. Okay. So, let us now try to solve this. So, etong y, let us just use 80 minus s. Ito. Or that would be 80 minus 16 t squared. Ayan. So, we have formed two right triangles pa rin. This and this. So, we could do ratio and proportion. So, let's start with the larger triangle. So, we'll have this is to this. So, that would be, this distance would be x plus etong distance, which is 20. So, that would be x over plus 20. So, x plus 20 is to 80, as eto x is to y. So, x is to y. Okay, and remember that y is 80 minus 16t squared. So we'll have x plus 20, that's equal to 80x over 80 minus 16t squared. Okay, so pwedeng ganito na lang. Para di tayo with respect, di tayo mag quotient rule, we could rewrite this as 80 minus 16t squared times x plus 20, that's equal to 80x. Now, if we want to get dx over dt, let's just get the derivative of this implicitly with respect to time. Okay, now let's get the derivative of x with respect to time, pero implicit lang. Implicit yung approach natin. So let's copy the first factor here. So 80 minus 16t squared times the derivative of this with respect to time. So that would be dx over dt. That's the derivative of x with respect to time plus 0. Okay. Plus, copy the second factor, x plus 20 times the derivative of this with respect to time. So variable natin dito time. So, no problema. So that would be negative 16 times 2, 32 times t times dt over dt. So that's just negative 32t. That's equal to 80 times the derivative of x with respect to time. That's dx over dt. Okay. So we have now this formula. If we simplify this, we'll have 80 minus 16t squared times dx over dt minus 32x plus 20, that's equal to 80 dx over dt. Okay, so if you notice the formula, pwede natin ma-solve yung dx over dt because the condition is that what would be dx over dt when t is 1 second. So ito yung nakasulat dito. How fast is the shadow of the ball moving along the ground? So ito yung define nating movement niya from this point. No, from this point it will end up at this point lang. So ito yung movement niya ng shadow. So what would be, how fast would that change or that movement be along the ground 1 second later? So yung hinahanap natin is dx over dt when t is 1 second. So we can substitute 1 here, pero we still need to get the value of x at that condition. Okay, so ang gagawin natin, we'll solve for x when t is 1 second. So we'll use the original formula, ito, because galing to sa ratio and proportion sa figure. So if we use this formula, we'll solve for x. So solving for x when t is 1 second. So let's do that. We'll have x plus 20, that is equal to, 80x over 80 minus 16 times 1 squared. So if we use a calculator na lang tayo. We'll have x plus 20, that's equal to 80x over 80 minus 16 times 1 squared. So if so, x is equal to 80 feet. So therefore, ito yung condition natin. When t is 1 second, x is 80 feet. Now let's solve for dx over dt. So we'll use now this formula, or this equation, this equation. Okay, using this equation, okay, that will give us 80 minus 16 times 1, so 16 times 1 squared, times dx over dt minus 32 times 80 plus 20, that's equal to 80 times dx over dt. Okay, to solve for dx over dt, we'll just continue this. So we'll have 80 minus 16, that's 64, dx over dt. Let's transpose this to the other side. We will have minus 80 dx over dt, that will be equal to 32 times 100. So therefore, we'll have dx over dt, that's equal to 3,200 divided by 64 minus 80. So we'll expect that the answer is negative because, of course, as I've explained kanina, x is decreasing. Or the effect of dx over dt is to decrease the value of x. Or simply, x is decreasing. So of course, dx over dt should be negative. Okay, so we'll just use our calculator. Okay, let's use our calculator. We'll have 3,200 divided by 64 minus 80. So the answer is negative 200. So the value, oh no, the rate of change of the shadow after 1 second is just negative 200 feet per second. So this is our answer. Very easy. Okay, so we'll have this as your assignment. A trapezoidal trough has cross section in the shape of a trapezoid, of course, having three equal sides of 1 meter respectively, and whose sides make 60 degrees with the vertical. Water is flowing into it at the rate of 3 cubic meter per hour. Okay. How fast is the water level rising when the water is 50 centimeters deep? Okay. So you just research ano yung trough. Okay. So that will be your assignment. Okay, let's proceed to our last problem. If y is equal to 7x minus x cubed and x increases at the rate of 4 units per second, how fast is the slope of the graph changing when x is equal to 3 seconds? So this is quite easy because given siya na x increases, so meaning dx over dt, with a rate of 4 units per second. So 4 units per second. So yung hinahanap natin dito is how fast is the slope of the graph changing. We know that slope is y prime, di ba? So we are trying to get the rate or the rate of change of the slope. So that's dy prime over dt. So yung hinahanap natin. The condition is when x is equal to 3. Okay? Okay, so first, anong pwede muna natin kunin? Let's just get the equation of the slope. So since we have y is equal to 7x minus x cubed, the slope is just y prime or dy over dx. So dy over dx is just 7 minus 3x squared. Okay? Okay. Now, if we want to get the derivative of this with respect to time, that would be dt of y prime is equal to the derivative of this with respect to time is 0 minus 3 times the derivative of x squared with respect to time. So that's 2x times dx over dt. So d over dt of y prime, ito na yung hinahanap natin. That would be equal to negative 6x times dx over dt. Again, so when x is equal to 3, so d dt of y prime is equal to negative 6 times 3 times dx over dt given 4 units per second. So times 4. So the answer is negative 72 units per second. So that's it for this week's lesson. Don't forget to pass your assignments before the week ends. See you next video.